Yes. Hey, he didn't take 5 minutes. I get this time, right?
No.
What? All right. So let's ask quickly to give a quick overview of what Waffle Grid is. Hopefully, some people have heard of it before, but Yves and myself have put this together. Basically, it's the same reason why everybody's out there building all these giant appliances, is to overcome limitations with your disk I/O. You have these giant data sets, they won't fit into memory, so performance starts to drop. What do you do? And people add hardware, they add shard, they do all kinds of crazy stuff. But what we decided to do was extend the buffer pool by actually writing buffer pool pages out to Memcache. So if you take a look at the how it works slide here, when a page needs to be read from disk, you have to expunge something through the LRU in InnoDB. And when you do that, instead of actually just throwing the page away, we end up sending it to Memcache. And then when we need to get the page, we retrieve it out of Memcache first, and if it's not there, then we go to disk. So very simple process, very quick code. So a couple things that we had to do real quick. We did have to change Memcache a little bit. Memcache had to be changed. Instead of doing an LRU in Memcache, so when you access the page, it's not going to get expunged. We needed to expunge it as soon as you access the page because you don't care about it in Memcache after it goes back into the InnoDB buffer pool. We had to do a little bit of changing around with the libmemcache. Also, we're very network sensitive because we're trading disk I/O for network I/O. So instead of having a 5 millisecond, let's say discrete, you have a 700 microsecond network read. So if you have 100 meg or 10 meg connection, it's going to be really, really slow. Numbers. So this is just a quick Sysbench read-only test. So you can see that by splitting the buffer pool between Memcache and local, we got about 600 transactions per second, whereas with a 1500 all local buffer pool, got about 660. So very close, which is what we want to see. And then we're also working on a plugin version that will work with 103. And here's some numbers from there. This is BBT2. You can see that going over 1 gig E, we moved from 4,000 TPM to 10,000 just by adding that small 768 meg buffer or Memcache server. And if we do local host, which is even faster, we get up to 1,400 TPM. Oh, and some of our tests we're playing around with some other features, but we can get all the way up to 20,000 TPM, but it's not stable. So if you want to try it or look at it, wafflegrid.com or Launchpad WaffleGrid, you can download some code and play with it.
Because they're so short, we're going to avoid questions in general. Yeah.
Sorry.
There's only one button.
You are last, okay.
I thought I had 10 minutes, so I guess I'll go really fast through the slides.
We like to change things up.
So I wanted to talk a little bit about some of the replication tools that right now is using, basically how we use replication and MySQL dump and MySQL binlog. Little history about right now, we're a software as a service CRM company. We're most known for customer service and our FAQ system to avoid people coming in and asking questions to call centers and that sort of thing. We do about 40 million page turns per day. We get about 70,000 queries per second. One thing that's kind of unique about us is we have about 3,300 unique schemas because every customer is in their own schema. So it's kind of a unique challenge for us. All of our queries are dynamically generated by our customer's design, which makes it particularly challenging for us. We currently have 300 production MySQL instances, and some of our servers have 100,000 plus tables on it. And that's something that most people don't usually have. We currently have about 21 terabytes of data distributed amongst those servers, and we have 4 copies of all our data using MySQL replication. And we've been running since 2000, and back in 2001, Monty actually logged into our servers, and he was up all night. He compiled GDB on our servers, and was up all night fixing the code until he got it stabilized. So it's just a little history there. Some of the uses of MySQL replication, we use MySQL dump, MySQL binlog. It's all built-in tools. There's lots of interesting things you can do out of the box with MySQL. With those tools, we do dual master replication, auto failover for those dual master replication. We have read-only slaves. We auto failover for reporting to the best server, and I can go into details on some of this a little later. We have a tool called Transporter that we can move between different masters that aren't replicating to each other. We compare master and slaves using checksums. We have rolling DDL, which a lot of other talks have talked about how they do that. All of our tools are written in Python. BATKit does a lot of the same things that we wrote, but it's written in Perl. If it was written in Python, I probably would use it because it's kind of a central piece of some of our infrastructure. Python is. But, our dual master replication failover, it's similar to the MMM project. I don't know if anyone knows about that, but it's called MySQL Master. We've successfully been running the dual master replication since 2003, and we achieve 99.998% uptime using that, and I think that's good enough. I don't need 5 nines uptime. So it works very well in practice. And we check MySQL once every 2 minutes, and we fail over if it's unresponsive within 2 minutes. And all of our failures are usually either disk or RAID controller related, which is pretty typical. Here's our architecture a little bit. It's kind of an old thing. It just shows basically what the different configuration between the masters and the slave. So we have a 4-node cluster, and we have lots of those. We do auto failover to reporting slaves. We move reporting to different slaves based off of a bunch of different, it's a sorting algorithm based on availability, proximity, buffer pool size, load, and seconds behind. And we take that all into account and sort it to the right master, the right slave based off of that. We have a bit mask value off of every report that goes through our system that indicates lots of things, and a couple of the bits that we set are if a report should go to the slave, and also if it should be deferred or not. We also have a tool called Transporter. We move data between non-replicating masters. This is something I think that it's a little, I haven't heard of many people that do this, but it's really easy, is that you can basically MySQL dump from the master into, from the slave into a second master, and then use MySQL binlog to catch up that slave. And here's some more details on that. So we basically grab the MySQL binlog, repeatedly run it until it's less than a second difference, and then we quickly offline and online the site to its new master. And we also do some checksumming during that process to make sure that we're not losing data as we're moving sites from master to master. We do similar things with comparing slaves. we wait till they're 0 seconds behind, we lock the tables we want to check, grab a bunch of information, master, pause, wait, and repeat, and you can basically lock it for a sub-second and get InnoDB snapshot and checks on the table. This is all with built-in commands in MySQL. And one of the nice things about this, I know MacKit does similar things too, is that we found dozens of replication bugs because of this implementation. So we're constantly checking our masters and slaves, and we find all kinds of differences, and we try to go back and figure out why those differences exist, and lots and lots of bugs. There's more bugs. I just haven't had time to even track down some of them because there are lots of race conditions. We do rolling DDL, similar to what a lot of other people talked about. We add delete columns indexes on the slaves in parallel, which means on all the slaves at the same time. Then we fail over master to secondary, and then run it on the master, and then come back. Some of the other tools that we recently created, we have a MySQL Guardian script that watches the threads and load on the server and takes escalating measures if we think we may incur downtime. So the higher the threads get, the higher the load gets, the more proactive measures, so we don't have to have a DBA up all the time. If the loads, basically someone to log into the machine to fix a load problem, it basically takes care of most of that, eliminating most of our downtime. Some of the things that right now is done in the past is we've done a lot of sponsorship with MySQL in the past. We sponsored the InnoDB file per table option. We had Heike actually code that up a long time ago. Timestamp with time zone support, a lot of other features that we've been long-time users of MySQL, and a lot of the focus we've had is just on replication stability, making sure the master and slaves match, and optimizer stability. We add a lot of the options, nulls equal, nulls ignored options, and pushing on subquery optimization. That's finally coming in MySQL 6.0, so that's good. Actually, 5.4, sorry. I just wanted to say a little thing about Percona here is that it solves a lot of performance problems. It solves a lot of stability issues in production environments. Some of the tools they added, the adaptive checkpointing. I don't think people realize how big of a problem this is in a lot of production environments. Basically, without the adaptive checkpointing patch, a lot of customers don't realize that they have these big hits with the checkpointing where none of their transactions, it just falls off the cliff. So some of those things that really help with our performance and reduce downtime a lot. With our IO patches, the LRU on the data dictionary, these are all long-time things that we wanted for years, and it's nice to finally see it come out there. And it's making a huge difference in production installations, and I think it's really great the work you guys did there. Some of the MySQL Wishlist for the future that I wanted to throw out there real quick was I just wanted MySQL to work with the community. I know that a lot of people have said that before, but I hope that they actually do that. Some of the things I've been wanting for a long time was optimizer improvements. The merge union optimizer needs to work in most cases. Right now it has a lot of issues. It needs to work with in clauses, with range scans, and correctly look at the available costs and choose the right combination indexes. With our 3,300 schemas, we can't add every combination of multi-key indexes to keep performance up. So that's one thing that we wanted for a long time. Another problem that I want to fix is rows per key estimates in InnoDB are not accurate. They need to ignore nulls. They need to keep their stats after restarts so they don't constantly get the wrong values. Basically, they can change dramatically between each dive, random dives into the index, so I think those are problems that we need to solve. There's my last slide here, is some other wish list things. Here was multi-threaded replication. I know that there's supposedly a build out there that's test code for that, and I look forward to testing that. Some other ideas on improving performance are improving sort files. They're all fixed length bar cars with UTF-8 data, and it creates huge sort files, and that's a big problem. Another thing with sorting is that when you're doing an order by 4 different sorts, limit 10, it shouldn't be creating 4 2 gigabyte sort files. It should only create 1 and then a partial on the following ones after that, based off of the top 10. And also, there were some improvements to query cache I wanted. But that's it. Sorry, it took a lot longer than 5 minutes, really.
No, Mark, because Mark was one of the ones on the original list, so I'll get you to come up. That's okay. Yep. And then we'll see how we have time for others. Which one, sir? Yeah, there's no just standard. Yeah, I would. Well, we had the original list. I don't have that on page. You want to go next? Okay. You want to go?
Hi, I'm Mark Leith. I work with the MySQL support group. I don't have any fancy slides. I was kind of roped into this by Morgan. I was asked to talk about two variables that I added to the InnoDB storage engine, both customer related. The first one I actually did for Ryan. It's a variable called InnoDB _stats _on _metadata. InnoDB in the background, when you actually go off and hit the information schema tables for the tables or indexes, the statistics table, or show table status or show indexes, in the background will go off and do essentially what's an analyzed table in the background for every InnoDB table. And that can kind of cause plan instability for explain plans and accesses. So Ryan wasn't very impressed with that. So I created this one variable which was pushed into 5.1, which turns that off. So if you see any kind of plan instability on your accesses for InnoDB tables, then take a look at that one variable and that will turn it off for you. The second one, God, I can't even remember what it was.
Adaptive hash.
Yeah. Well, we had this bug InnoDB had this bug, bug number 20358, I think it was.
Sure.
Yeah, it affected a hell of a lot of customers. Basically what was happening was there was a race on semaphore locks, I think, and basically the semaphores inside InnoDB would deadlock and lock up the server. Internally, if InnoDB has a semaphore lock that lasts for longer than 700 seconds, it will basically crash the server for you. And we couldn't reproduce that internally in support. It was really hard for us. If you could see the number of support issues that were actually associated with the bugs, it makes the screen about this wide. So we basically had to try and work around it. And this internally, InnoDB has this one little flag that basically says use the adaptive hash index or not, but it doesn't surface it up to the to the variables level, so you can't turn it on or off. So I added that as well, and that got pushed into 5.1. If you were in Ken Jacobs' talk, he actually referenced it and said that they pushed it into 5.1 in their plugin as well. And that can also be useful in certain workloads, because with the adaptive hash index, what it does is if you access the same rows over and over and over, it will then, it keeps track of how many times you access it, and if you access it many times, then it will push that, the index pointers into the adaptive hash. If you're not reading those rows very often, or over and over and over, there's no reason to actually keep track of those in the adaptive hash index. So some workloads, it's actually pretty good to actually turn that off. So give that one a try as well and see if that's any good for your applications and your throughput. And that's pretty much it.
My name is Susanne Ebrecht and I'm working on MySQL support team. I thought we are on a performance conference here and we heard lots of talks about performance in the computer, and I want to make a talk about performance, that is performance issues that are sitting in front of the computer and happening in front of the computer. I worked in my past life, I worked for two really big companies as DBA, and we were responsible for big databases, and we used some very weird graphical tools. I think we used AutoCAD or something like this to create a diagram for our database. The diagram has had 6 square meters. We printed it out and sticked it on a wall. It really has had 6 square meters. And every time when a software developer called us and said, hey, it would be nice when I can get a view for the select statement, or it would be nice when you will implement this function in the database, or something like this. So even we as DBAs just could look on the wall, how is the name of the table, what are the names of the columns. And also it was easy for us when one of the departments or the software developers of the departments came to us and said, oh, we need information, which tables do we have in the database? So we just could print out a small piece of paper of the schemas for these departments, and we could just hand out a diagram, and they have had an easy job. They just could look onto the diagram and figure out how are the table names, which data types are in it, and how are the names from the columns, which functions are available, which conditions are there, which indexes. That was positive, and that was really fast, because looking on a piece of paper is a very fast process. I was the first female developer in PostgreSQL, and I had to look up and also I worked for Informix and in both I had to look up, I needed the informations of the system database, and when you know the Informix system database, that is a huge numbers of tables, same in PostgreSQL, and my Informix experience is lots of years ago. It was before Google and before documentation was in a computer. So I have had a book about Informix, and because I'm German and it was in Germany, it was in German, and the translator translated all names of tables, columns, and so on. So, and also it wasn't a schema in it, it was just a list of the tables. It was horrible to figure out what is what and where to find it. The PostgreSQL documentation has an alphabetical order of the tables, also documented, but you need some time to figure out what is what and what do I need and which data types. A diagram would be nicer. And MySQL has a nice new tool, it's called Workbench. And Workbench has the option for reverse engineering, so you can take your database and click on reverse engineering and you will get out a diagram from your database. which is very nice. Of course, you have to make it a little bit nicer, but it's a very nice tool and it will save lots of time for the software developer when you just look on a diagram. And I just can recommend trying MySQL Workbench because it's a really, really nice tool. Yeah, that was the question.
So I'm continuing the flood of support engineers on the stage here. I'm also a bit sometimes known as the Wikipedia guy. And well, as I run some Wikipedia databases, I kind of sometimes have the task of dumping data and loading data. And as you might kind of imagine, I'm quite bad at charting sometimes. So we have databases like half a terabyte on a single instance. And loading or dumping and loading and dumping and loading is kind of a complicated thing in the end. Simply how to do that when you have lots of disks, but MySQL dump is quite slow. So what I actually did back then, well, quite a few months ago, I created a tool, MyDumper. It's a launchpad. It's called, well, MyDumper. Stupid name, but it kind of couldn't come up with any better idea. So what it does is, first of all, it is a MySQL dump kind of improvement, new product that is simply 10 times faster, at least on my workloads. What it does, it just simply connects multiple threads, it establishes transactions, a consistent snapshot across all the threads, and it just dumps it in parallel. The side thing was it was written in a C. I am not a good C programmer, so I couldn't write enough of clever C that would slow it down. So it's right now faster at single thread than MySQL dump as well. So even with a single thread, it's faster. And in the end, I end up like having multiple chunks for tables with this. It can do compression quite efficiently. It's kind of it does the work. It doesn't dump the schema object DDL. It just dumps the data and it puts into a separate file per table, a nice directory, nice naming. It puts the metadata for slave status, master status. And then the only thing that's remaining is loading it. And loading can be done in two ways. One way is using experimental software written by, well, the same guy standing on the stage, which is called Paramine. It takes the SQL stream and then executes that in parallel. And the other loading way is simply use Unix utility, which is xarg. It has the max processes parameter, which allows simply one xarg instead of running command after command seriously. It can load them in parallel. So what happens then? We kind of parallelize the load that parser does. So parser overhead is eliminated if you have multiple threads when loading your data. You can disable checksums that again simplify some of the loading. And in the end, you're hitting the mutex. And that mutex, the log sys mutex is hit for every row that is changed, for every row that is inserted, a mutex is grabbed. So you cannot really, but MySQL in this case does not scale beyond two threads. You can improve the speed when loading in parallel just 2 times on InnoDB, but no more. So my reason on the stage is just whenever anyone has any ideas how to eliminate that mutex, just go and do that. Community will just love you, and we'll have the tools are out there that will benefit on that. And of course, you can use the tools. The MyDumper is on the Launchpad, and it's running right now. It has even stable versions right now. I mean, really, we are running versioning and kind of did the engineering to make that work on multiple platforms. So go on, try it, and once you are happy with it, just go and fix the new performance problems then.
The loader is called what?
Loader is, I usually just suggest using xarg's functionality and running multiple MySQL processes. But there's a Paramine. If you look at for it on Google, you'll probably find just my blog post with a link to SVN. It's way more better. It's alpha, it's pre-alpha compared to MyDumper. MyDumper has quite good code quality by now. And yeah, it's probably the fastest solution to do the logical backup. It's not I guess the only way to do things a bit faster, but that will be able to do a physical backup is just copying the data files.
Good.
Okay, so the next thing starts at 9:05. That's
As a second, I need to get them into an InnoDB table. Typically about 30 million records in a day. So I was getting fairly good performance until I hit my table size hit the NFDB buffer pool size. And that's when insert rate just dropped to 400, and then 200, and then in the single digits of inserts per second. So I even pushed it up. I started doing bulk inserts, so doing 40,000 rows inserted at one time. That got me 10,000 inserts per second until I hit the InnoDB buffer pool size, and then it went to 400, 200, and single digits. So then what I did was tried partitioning. So the best thing to do is partition based on your primary key so that reads are good. Again, the same problem because now your inserts are going into multiple partitions at one time. So once the total size of those partitions went over InnoDB buffer pool size, it went out to 400, 200, and single digits. So then I got this brainwave. Why not partition based on the insert key rather than the read key? So I changed the partitioning scheme to be based on the order in which the records were coming in. And now it's only inserting into a single partition at a time. And each partition is always less than the InnoDB buffer pool size. So I get a consistent rate of 10,000 inserts per second forever. I've now got about 700 million records.
So the partitions, what underlying, what engine are the partitions?
It's InnoDB, so it's InnoDB in 5.1. You can just InnoDB and MySQL both support partition. That's it all.
Yeah, if you can do 1 minute.
Yeah.
Lightninger.
Hi, my name is Lee from Answers.com. We have two sites, Answers.com and WikiAnswers.com. Our wiki site has quite a good amount of rights to it. We have a data center in the U.S. and a development center overseas in Israel, in Jerusalem. We like to keep a live replication slave in Jerusalem so the developers can make copies of it to play with. And we're oftentimes challenged by the bandwidth of getting a 60 gigabyte targz over to there, which is constantly being updated. The master is being updated with new queries all the time. So what I came up with was to I remove the instance that we have in Jerusalem. I copy only the master info from the latest snapshot. I start up replication and it crashes immediately because there's no data to write to. It can't start writing anything. It says no database table is not found. And once I've started that process, I then start copying over the tar. Sometimes it takes up to 24 hours, but during this time, my relay logs are accumulating. So when I finally get the whole tar and export it into the directory, just restart MySQL and it just executes all of the everything, and I'm good to go. After I came up with that idea, I then realized I could do it in a more organized fashion by using by starting only the I/O slave instead of having to crash through the database. And then after I get my tar expanded, then I start the SQL slave. And that's what I wanted to share.